Section 5.3 is using the sum and difference formulas for the cosine of a plus b or the cosine of a minus b. So you'll want to have your identities and formula sheets handy because you're probably not going to memorize these. You're just going to reference these. So the first things that we talk about are doing these without the calculator. So if you had the cosine of 105 and you didn't have a calculator, you could think, well, are there two angles that I know the trig functions for that would add up or subtract to give me this value? Well, 105, you can add 60 and 45. So 60 becomes your A and 45 is your B. And when you look at the formula, cosine of A plus B is cosine A cosine B minus sine A sine B. So you just, maybe write the formula down and then plug in. So the cosine of 60 is 1/2, 45 is square root of 2 over 2, sine of 60 is square root of 3 over 2, and square root of 2 over 2 for sine 45. Then you're multiplying. You get square root of 2 over 4 minus square root of 6 over 4. They're the same denominator, so you can write your answer like that. All right, now those are not quite so hard. When you look at something like the cosine of negative pi over 12, well, that's not one we know, and we don't typically think in radians. So you want to think about fractions. So if you're looking at twelfths, pi over 6 is 2 twelfths. Pi over 4 is 3 twelfths. Pi over 3 is 4 twelfths. So if I want a negative 1/12, I could do pi over 4 minus pi over 3. That's 3 twelfths minus 4 twelfths would give me a negative pi twelfths. So you this becomes handy to just think in twelfths. So you do cosine of pi over 4, cosine pi 3, plus sine pi over 4, sine pi over 3. Do the same thing. Plug in the values that you know, multiply across square root of 2 plus square root of 6 over 4. Very similar to the one we had up there. All right. Then we also get some cofunction identities at this point. The cosine of 90 minus theta is equal to the sine of theta. Sine of 90 minus theta is equal to cosine theta. Tan and cotan go together. Secant and cosecant go together. And how that looks is you're going to have two numbers that add up to 90 degrees. So cosine of pi over 3 equals the sine of pi over 6, because that's 60 degrees and that's 30 degrees, and that adds up to 90. Cosine of 40 is the same as the sine of 50. Tan of 12 is the same as cotan of 78. So the cofunctions are here, and the numbers will add up to 90. So if you said write in terms of cofunction of the complementary angle, and you were given tan of 87, you get cotan of 3. Cotan of 9 pi over 10. So you want to think about pi over 2 is 90. So to get the right angle, remember they have to add up to 90. So pi over 2 minus 9 pi over 10. Have to get a common denominator, which is 10. 2 into 10 is 5. So 5 pi over 10 minus 9 pi over 10 equals negative 4 pi over 10. That reduces to negative 2 pi over 5. All right, and so we practice a little bit more with those. The cotan of pi over 3 is the same as the tan of pi over 6. This one says find the angle that makes the statement true. So you've got this statement here. The tan of theta is equal to the cotan of 45 plus 2 theta. Well, what we do know is that this and this have to add up to 90. So 45 plus 2 theta plus theta equals 90. We have 3 theta. Subtract this 45 over here. So we have 3 theta equals 45. Divide by 3. theta must be 15 degrees to make that true. And the last kind of problem that we're going to do is a good bit of work, but it's using the sum and the difference. So it says find cosine of s plus t and cosine of s minus t. Given sine s is 2/3 and sine t is negative 1/3. S is in quadrant 2 and t is in quadrant 4. All right, so the process for solving these is to draw a right triangle for each angle. They tell you which quadrant. It's really important to draw them in the correct quadrant so you get the positives and the negatives. So this one says sine s is 2/3 and it's in quadrant 2. So always draw out from the origin and then back to the x-axis. So if the sine is 2/3, that means 2 is here, 3 is here. You have to solve for the missing piece. You do that with a squared plus b squared equals c squared. And so I got that x was square root of 5. Because it's over here on this part of the x-axis, it has to be a negative square root of 5. That's important. For the one in quadrant 4, out from the origin, back to the x-axis. And we were given sine was negative 1/3. That would be opposite over hypotenuse. Negative here. R is always going to be positive. So again, we have to find this number. We found that it was 2 square roots of 2, and it is positive. So after we have found those three parts, we can figure out what cosine is in each triangle. Over here, cosine is negative square roots of 5 over 3. Here, cosine is 2 square roots of 2 over 3. I boxed those. So now I have sine and cosine for each of those. And now you use your formulas. The cosine of s plus t equals, here's my formula. Plug in what I had gotten on both and end up with this amount. Square root of 5 times this, you get 2 square roots of 10 over 9, and it's negative, minus 2/9, and it's negative, so that becomes a plus. So you have negative 2 square roots of 10 plus 2 over 9. And you would do the same thing to get the other one. You would just fill in. So you have, I think you have one of those on your homework where you have to draw the triangle for each one. It does take a little bit of time, but that's how you would do that. Let's go look at your homework problems. So the first one is really just making you come up with the formula that forms an identity. Cosine of x plus y equals cosine x, cosine y, minus sine x, sine y. All right. Find the exact value of the expression below. Cosine of 75, that's not one we know, but we know that 45 and 30 add up to 75. So cosine 45, cosine 30, minus sine 45, sine 30. Square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. We get square root of 6 minus the square root of 2 over 4. Cosine of 105, that's like the one we did in the lecture notes. And that's exactly what we got. So I'm not going to go over that problem again. We did that. I did that one in the lecture note part. Cosine of 5/12, 5 pi over 12. So again, we talked about using 12s, and 5/12 is 2/12 plus 3. So that's pi over 6 plus pi over 4. So that's what we're going to use. And we do cosine of pi over 6, cosine pi over 4, minus sine pi over 6, sine pi over 4. Fill in your amounts, simplify, and you end up with this. Number 5, use the cosine of a sum and cosine of a different to find, and this is that last kind of problem that we did. So we have cosine s is 2/5 and sine t is 3/5. They're both in quadrant 1. So when I did it, I drew s is here and t is here. They're both first quadrant. That means everything's positive. Cosine s is 2 over 5. you had to find the missing piece. So then I wrote that sine s was then square root of 21 over 5. So you've got this one, you've got cosine here, and a cosine here, and you've got a sine here, and a sine here. Okay, so now that you've got all of those, you can just go to your formula, plug them in, 2/5 times 4/5 minus square root of 21/5 times 3/5. You end up with that, and you end up with 8 minus 3 square roots of 21 over 25. They're kind of weird answers, so don't worry about that, but that's what you should get. And then when you do the minus, remember that that's just going to change the sign in between. Okay? All right, and then number 6 is the same idea. They are both in quadrant 4, which means we're going to have y values that are negative right here and here. So you plug in what you're given, square root of negative square root of 2 over 4. So negative square root of 2 over 4. Find your missing piece. It's x equals square root of 14. So now we have cosine is square root of 14 over 4. And do the same thing over here, and you have your sine and your cosine. Plug those in. Now you get really big numbers here. Let me make this smaller to fit on here. So square root of 14 over 4 times square root of 31 over 6 minus, and you got that. So you have square root of 434 over 24 minus square root of 10 over 24. They really don't simplify any more than that. So those are going to be some crazy little answers there. And then over here, you've got the same thing. Let's see. So you've got the same thing except the sign. The sign right here will be positive because you had positive different in the formula, and here you had a minus times a minus, so it ends up being totally positive. Here you had minus, and you had minus times minus. So the only difference is that symbol right there. So that should get you through that 5.3.